Hello, we're about to do homework 3, question 9, and it asks us to solve for df of x over dx using both parts of the fundamental theorem of calculus. So let's go at it. So it gives us the integral from 0 to 5x, 5 to the x power of e to negative 4t dt, and it tells us to take the derivative and find df of x or dx. So using this, the second part of the fundamental theorem, we're going to use u substitution. Let me erase this. Let's say that u is equal to negative 4t. So du to the negative 4 dt. So once you do a substitution, I want to remove this mark for now because we're first going to take the integral and then take the derivative. So as we move on, it'll be negative 1/4 from x to the 5th, or from 0 to x to the 5th of eu du. And then we take derivative of this and we put that constant in, and we get eu over 4 negative from 0 to x to the 5th. And then we want to substitute back negative 4t into the equation. Get negative e and negative 4t over 4 from x to the 5th, 0. And once you plug in, you will get negative e to negative 4 x to the 5th over 4. It's a bad looking x. Over 4 plus 1/4. And now we have to take the derivative of this. I'm moving this side. And what you get is that we can factor out the negative 1/4 out and be d over dx of e to the negative 4 x to the 5th minus d of dx of 1. And you will get negative 1/4 times the quantity e to negative 4 x to the 5th. And since it's a function within a function, we need to use chain rule. We multiply that by negative 20 x to the 4th. And after simplification, the answer is 5e to negative 4 x to the 5th times x to the 4th. So that's the answer using the fundamental theory of calculus part 2. However, it's a little bit different once you use part 1. I want to demonstrate this. I'm going to erase this for now and put the answer right here. 5e to negative 4 x to the 5th times x to the 4th. And one thing that you need to know about the first part of fundamental theorem calculus, to solve the same way we did here, we're going to figure out what du over dx is. We're going to also solve what df of x over du is. And once we have that out, we're going to multiply them so we can cross out the du's, and we'll get our df of x over dx, which is the same thing we got here. So given the integral 0 to 5 x to the 5th to e to negative 4t dt, we're going to pick u, and u here is going to be x to the 5th. Sorry, du or dx is equal to 5x to the 4th. So we know what our du dx is, so we're going to leave that to the side. And now we can substitute the u into the integral from 0 to u, e to the negative 4u. We had to replace the u with t, or the t with u. The u, we replaced the letter, and du. And now that we take the derivative of both sides of this, using the fundamental theorem of calculus, we know that what we'll get out of this will be we know that once we take derivative of this, because this itself is uppercase f of u, and that when we take derivative of this, we'll get f of u. This is the antiderivative. And once we take the derivative of the antiderivative, we'll get the actual function. And so using the fundamental theory of calculus, you could get f of u to equal e to the negative 4u. And that's f of u. Well, actually, hold on. I'm sorry. So this right here is actually f of x. And we're getting the derivative of fs. I'm sorry. So what we had here is already f of x. This is our f of u. And we're going to get the derivative of f of u, which would be the d f of u over dx. So once we do that, we get d f of u over du is equal to e to negative 4u. And now we're going to plug these back to the equation. Du over dx is equal to 5x to the 4th times df of x, which we're going to replace the u here with our substitution. So this is actually equal to e to negative 4x to the 5th. So it'll be that times this number here, e to the negative 4th x to the 5th. And you get the exact same answer as you got here. Thus proving both the fundamental theorem calculus, part 1 and 2.